Okay, we are going to begin level 1 of area and perimeter. What we have here, this is a rectangle. We know it's a rectangle now because it has 4 90-degree angles. The 4 90-degree angles mean that you can divide it up. So everybody, how long is this side right here? 6. What that means, sort of, is that it goes like this. There's 6 bars this way. 1, 2, 3, 4, 5, 6. And how many would there be this way?
5.
5. So then 1, 2, 3, 4, 5. So if you added up all the boxes here, how many do you think there would be?
30.
30. You guys all know how to do that, right? So all area really means is how many boxes would there be. So when there's 6 going this way and 5 going this way, you just multiply. So what would the area of this rectangle be? 30 what? Units squared. Okay?
Why units?
Because if nothing is listed, it's units. If it says inches, it's inches squared. If it says millimeters, it's millimeters squared. If there's nothing listed at all, you call it units squared. Okay? Another thing to know is a little bit of vocabulary. The distance that goes this way, we call the base. So that's B. The distance that goes this way, we call height. So this is the formula that we use for the rectangle area. Base times height. So the base being 6, the height being 5, 6 times 5 is 30. Pretty easy. Okay. Perimeter is also pretty easy, but let's think about this. If it's 6 on this side, how long is it on this side?
6.
6, sure. We know that because the sides are equal. And if this is 6, what's this one going to be?
5.
5. All you got to do to find the perimeter of anything, sum. What does sum mean? Add. Sum of all sides. So 6 plus 5 is 11, plus 6, 17, plus 5 is 22 units. Quickly tell me, why is area units squared?
Because we only do half of the square.
No, because you multiply? Okay.
I don't know.
The best reason is that area is 2-dimensional. It's 2-dimensional, like it's a plane, right? So things that are 2-dimensional are squared. Perimeter is units because perimeter is a distance. It's just how far something is. So it's how far is it around this figure. So area is always squared. Perimeter is always units. Okay, next one we've got this triangle. So this might be a little harder. We can divide this up into 6 things.
Bars.
Yeah. 1, 2, 3, 4, 5, 6. But are they all the same length?
No.
No. This one is 8, right? This one over here is all the way down to 0. You guys see that? So the best way to think about a triangle is that it's actually half of a rectangle. Does everybody see that? If it's half of a rectangle, then we're going to take that base times height, and we're going to divide it by 2, because it's half of a rectangle. Does that make sense to everybody?
Yeah.
Okay, so what's the base of this triangle?
6.
What's the height?
8.
So what's 6 times 8?
A bigger number.
What is it? I'm sorry?
48.
48, there we go. And what's 48 divided by 2? 24, so the answer is 24 units squared. And area is always squared. Always. Okay, then the perimeter will be adding up the sides. So that will just be the 3 sides. 6 plus 8 plus 10. 6 plus 8 is 14. Plus 10 is
24.
24. 24 units. Okay. So that does it for the rectangles and the triangles. Our level 1 is actually going to have 4 figures. We're going to add now the parallelogram and the circle. So get ready. We're going to add parallelograms and circles. I think the rectangle and triangle are probably the easiest. Parallelogram and the circle, a little bit harder. Okay, so parallelogram looks like this. What word do you hear inside the word parallelogram?
Parallel.
Parallel. And what that means is that opposite sides are parallel to each other. So You guys remember what these little triangles mean that I'm
Parallel lines. Parallel lines.
Parallel. Good. Okay. I want you to notice something here, though. I want you to notice something here. What's the base of this parallelogram?
5.
It's not 5. 4. It's 4. The base is 4. You understand why it's 4? It's the side-to-side distance. Base is not this. Base is not this. Base is this. So what's the base of this parallelogram?
4.
4. What's the height of this parallelogram? Not 10. 13. Everybody get that? Okay. Does everybody see this triangle here? If I was to cut that off and put it up here, what would we end up with?
A rectangle.
Rectangle. Would you agree that that rectangle would be exactly the same size as the parallelogram? Yeah, because I'm removing a triangle and putting it somewhere else, so it would be the same size. Does that make sense? Would the base be the same? Would this still be 4?
Yes.
Yeah? Would the height still be the same?
Yes.
The 3 would be up here, but what's 10 plus 3?
13.
13. So it would still be the same height, right? So the base would be the same, the height would be the same, the area would be the same. For that reason, the area of a parallelogram is also base times height. Nope. It's just like a rectangle. It's not a triangle. Okay? Okay. So if the area is base times height, what's the base again?
4.
4. What's the height?
13.
13. So you just multiply. What's 4 times 13?
Really big number.
Not even. 4 times 13. I want to see your pencils moving.
4 times.
52.
What's 4 times
52 is
12?
correct. 52 what?
Units squared.
Units squared. Great. Now the perimeter, this is the one that people kind of get a little thrown off on. Is 4 one of the sides of this parallelogram?
No, it's the base.
No, it's the base, but it's not one of the sides. The sides are the outside.
No.
So how long is this side right here?
13.
13. How long is this side?
5.
5. This one?
13.
13.
5.
5. So 13 plus 5 plus 13 plus 5. So what is 13 plus 5? 18. 18 plus 13. 31 plus 5 is 36. And what do I write? 36 what? Units. Excellent. Okay. So copy, copy, copy. Make sure, if you're watching this on video, make sure to rewind. Marco, quick question?
So the area for all quadrilateral are
No,
is base times.
absolutely not. Parallelograms and rectangles, yes. Others we'll deal with later. Okay, I'm glad you're thinking that. That means that you're ready to hear the information. The answer is no. Okay, here's one of the easy ones. What would we call this thing?
Oval.
What would you call it if I drew it better? Circle. Okay. What do you call the line that goes all the way across?
Diameter.
Diameter. So if the diameter is 12, what would the radius be?
6.
6. How do we know this?
Because it's half.
Because it's half, of course.
And we're smart.
And we're smart. That's the most important thing, of course. Okay, so the area equals pi times the radius squared. Okay? The explanation for that takes some time. We're not going to trip about it. I'm giving it to you. Okay? We'll talk about it later. And we have a little bit more time to be philosophical. But right now we're just trying to work on using the formulas. So pi times the
3.14.
radius squared. We're going to just accept pi as pi. We're not going to call it 3.14. We're just going to write pi. So what's the radius again?
6.
6. So what is 6 squared? Listen.
Thank you.
I'm sorry?
36.
36. So the area will equal 36 pi units squared. Any difficulty with that? Okay. And then we want to find the perimeter, but we don't use perimeter. We don't use the word perimeter in a circle. Does anyone know what we use instead of perimeter? To mean the distance around a circle? Sounds like circle. Circumference. Yes, circumference. Sounds like an English knight. Circumference. He's from the region of pi. Okay. So the circumference works like this. Some people prefer pi times diameter. 2 pi r also works. In fact, I'll be happy to write both because there's no reason. They actually both mean the same thing. After all, 2 times the radius is the same as the diameter. So this and this mean the same thing. Do I need to say that again?
No.
Okay. What's the radius, guys? 6. So what's 2 times 6? 12. So it would equal
12 pi
12
squared.
pi units or
Unit.
units squared?
Unit.
Units. Nope. Only area is squared. Or let's do it this way. What's the diameter?
12.
12.
So it would be
12.
So obviously it's the same answer, right? Which it should be because it's the same formula, just written differently. Okay? Alright guys, best of luck with this. Rewind the video if you need help. And thank you.